Oh, good afternoon, everyone. My name is Mahendra Singh, and today I will discuss about the role of dry air intrusion over India during summer monsoon break. So I am working with the Professor Govind Samiwala and Professor Aswin Sastry. So introduction. So as during the break season, it is mostly found that that dry air intrusion from the mostly the west and east is it came over the northern part of India. So it is found that the dry air from the middle east of that desert into the Arabian Sea as well as the Indian continent, northern part of Indian continent, and that the Krishnamurti also said that this dry air intrusion can could be due to the subtropical high region over the West Asia, and they have also argued that this dry air intrusion can prolong the drought condition during the monsoon break season. And as we know that the active and break cycles are very important part of Indian summer monsoon. So this dry intrusion, the study of this dry intrusion can tell us about the break condition of Indian summer monsoon. So for this today, I will discuss about this paper, which is published in 2021, which is the title was the dynamics of a dry air intrusion over India during summer monsoon break. So so for that they have used a they have calculated a term that is called the saturation deficit or moisture deficit, which is the difference between the saturation specific humidity and the specific humidity. And the moisture deficit transport they have specified as the zonal component of the wind multiplied by that moisture deficit. And they have also identified they have also given an index that is called the dry air intrusion index, which is the vertical integral of that moisture deficit transport at a 70-degree east between 20-degree north to 30-degree north. So how they have calculated those dry air intrusion episode, they have defined that this index, if this index is greater than zero, at least for 3 days, consecutive days, then it is called as dry air intrusion day. And if it is less than zero throughout the monsoon break season, then it is called the this break season is like dry air intrusion free break season. And for that, they have used rainfall data from the Indian Meteorological Department and the TRM mission. And for like large scale meteorological variables like zonal wind, specific humidity, they have used for from the era interim data set. And also they have used the OLR and SST data from National Oceanographic and Atmospheric Administration. So they have mostly they have mostly done their analysis only for the July and August, as they have mostly the peak monsoon season happens in those months. So I would say most of the analysis for this paper is mostly done by for July and August. So here they have plotted the July and August uh, climatological precipitation and that moisture deficit at 850 hectopascal. So here we can see that mostly July and August time period, mostly the rainfall pattern is there. But the interesting thing here is that if we see the if we see the contour here, these contours are for the moisture deficit. That is called the saturation deficit. What exactly do you mean by saturation deficit? Saturation deficit means they have said that how unsaturated air in that region. RH, based on RH, it is based on the specific humidity. Like they have calculated the saturation specific humidity and they minus the and they did it minus by the specific humidity. So mostly the unsaturated part is only there. Same as vapor pressure. Vapor pressure. Yeah, we can say that. but in term of this like moisture content. So here is what we can see that here we see the contours here. Mostly the positive contours show that there is a moisture deficit is there. So mostly when we see the contour of 6 gram per kg, at like above this or above this value, mostly the rainfall is not happening in those regions. Mostly you can see that in the northern and western part of Arabian Sea. Same for both the months.
But then that is climatological, right? It's, you know that okay, they're very dry there. So
Yeah, so
information that you're providing us.
they just providing that whenever the like moisture deficit is there, so rainfall is not there in the climatology too.
Yeah, then okay, basically you have saturation with actual, but actual will always be low there.
Yes, sir.
What information is it providing for us? You know that okay, it doesn't rain, it is always dry. So your saturation deficit is independent of the conditions, isn't it? It's basically your temperature and
Yeah.
from that, right? So what is the information that
Mostly the information regarding the how like this could this is saying that the how like there is a boundary for above that is with moisture deficit, the rainfall is not in that region. Like here, like out of the 6 gram per kg, if there is that value is happening in that region, then rainfall is not there. Like we can see in the climate.
Is that since they're only for that region or market region?
This is mostly like they have calculated only for this Indian region. So mostly I have found this in the whole region is mostly the rainfall less or no rainfall there. So for that, so they have calculated like they have did some EOF analysis for that. So to identify which variability is happening in that region. So for that they have used did the EOF analysis for July and August time period, and they have found that the first EOF have given mostly the explain the 37 of variance. However, the second mode of EOF is explained 30% of the variance. So we here we can see that this EOF analysis is done on the zonal wind. So here we can see that the first EOF is mostly giving the condition of active monsoon like here. There you can see that the positive anomaly is positive EOF value is showing that mostly the monsoon jet is mostly like intense in the Indian Peninsula. However, whenever the second EOF is showing the break like condition as mostly the jet is mostly like positive giving over the like north of Arabian Sea. So here we can see that the whatever the dry air index they have calculated here they have plotted in the red for only 2009 just from 1 July to 31st August, and here we can see that dry air intrusion and the precipitation anomaly for the central India region, and they have mostly we can see that whenever the dry air intrusion value is high in negative and then in the dry air intrusion is high value, we can see that there is like a suppress of like reduction in the rainfall. So we can see that this index can explain during the break season. This like intrusion is affecting the mostly the center and the northern part of India. Yeah, this one. Okay, so 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 they have done the analysis for 1981 to 2014. For that, they have found mon- they have found that there are 34 break events when the dry intrusion playing a role. However, there are 4 months like break space are also there. There, though dry intrusion is playing a role. So here we can here we they have plotted the that is saturation deficit uh, and the wind vectors. So this is for those composite for those four monsoon break spell, and this is for when diffusion is playing a role. Then those are 34. So here you can see that mostly in that region, whenever dry diffusion is there, the moisture deficit is higher as compared to when there is no dry diffusion. Also, here you can also see that some like more moisture deficit is also found in the Bay of Bengal region. So, so here they have explained why like this is happening. So whenever the that monsoon low level, whenever it intensifies, it mostly induces the cooling of the Arabian Sea in the like in the west part and this part, the west part of India, west part of Arabian Sea. So what happens is mostly here. So what happens is whenever the jet intensifies, it mostly did the upwelling over this region and mostly cool down that region. So they developed a SST gradient over the northern part and the northern and this central part of Arabian Sea. So this acidic gradient did this acidic gradient mostly play the role in the like we can see that this acidic gradient mostly try to that wide the monsoon low level jet and this reaches further towards the north. Mostly during the active time, it mostly jet is mostly sharp and intense in the over the southern peninsula. But whenever the break phase arises, mostly this jet bites and this due to that like SST gradient. So to see that how during that intrusion phase, there are one slide. Okay, so during that intrusion phase, what happens is whenever that dry intrusion come over the northern part of India, so that dry air mostly did the atmosphere stable. So to see the stability of the atmosphere, they have plotted the equivalent potential temperature, vertical profile of the equivalent potential temperature for this region. This is northwestern region of India, and this is the central Indian region of India. So contour, so shading is for 34 spells, break spells when dry intrusion is playing a role, and contours are only for four, and where the dry intrusion is not playing the role. So here we can see that the when dry intrusion starts, like this is the lead that in that direction. So zero means the intrusion is started from that side. So here you can see that whenever an intrusion is started, mostly the negative uh, the negative equivalent potential anomaly is found, which suggested that the atmosphere in that region is more stable as compared to the normal condition. And similarly for the central India region, however, it is less intense compared to this region, but it is there. However, whenever this no intrusion conditions are there for contour, they have shown the positive values are also there. So it can be seen say that this dry intrusion mostly did the like did the stable we can say that it stabilized the atmosphere. So this stabilization of atmosphere can cause more like deficit rainfall conditions. Similarly for for seeing how this advection of this dry intrusion is happening there. So for that they have plotted the anomaly for zonal wind and specific humidity for a anisotropic level at 360 Kelvin. So here this is the like when the dry intrusion is maximized, and this is like before 4 days and 2 days and so on. So here we can see that whenever it approaches to that maximum dry intrusion, this the zonal wind is mostly positive in that region. That shows that it actually moves from that region, and in the specific you can see that this dry air, this dry and specific humidity mostly in like anomalies in negative. So you can see that this moves from west to eastward, and when it peaks during the starting of starting of the intrusion, and then it disappears. The similar feature we can see that whenever in the OLR, so it is like OLR during the break phase, we can see that the it move like positive anomaly is moves from the west to eastward, which is here you can see that, and this positive anomaly is moving from west to east. So these two somehow connected to each other. So they mostly did the dry conditions over the over those region, mostly central as well as northwest region of India. So here we can say that the dry intrusion is playing a role in moisture dry moisture transport over the northwest of India, and this low level jet undergoes a weakening and broadening. Mostly what happens is whenever during the break time, what happens that jet mostly it broadened and weakens. So it mostly reaches north of the Arabian Sea, and the presence of there that deficit moisture it transport toward the north of India. So this happens in the low level jet that it weakening and broadening in this break phase of monsoon might be responsible for increase in barotropic stability during the active phase. As whenever it is narrow and the barotropic instability, like barotropically it is unstable. That is why it broadens and it tries to stabilize the monsoon low level jet. So this effect is mostly due to the as we said broadening of the jet, and this is due to the SST gradient that I talked here. So here though, so before it is higher in the we can see that here it is high and here those gradient is higher, but whenever the dry diffusion during the dry diffusion this uh, it becomes lower. So this is kind of a feedback system when it is that low level jet is sharp than a gradient is higher. So due to that higher gradient, jet broadens, and this broaden of the jet again start upwelling in that region too, and that SST gradient beacons after on the day of intrusion and after that. So we can say that this dry air intrusion enhance the stability of the atmosphere over north and central India, that further intensifies the dry conditions over those region during the monsoon break. Thank you.
Only what dry air intrusion from this center from multiple problems.
Yes, sir.
Okay, that's so many ideas. So what is the issue in this work? That is number one. And then this, if the SST gradient is playing a role, the key mechanism, then the dry air intrusion won't be there in an atmospheric only model. But there's several atmospheric models. Active break cycle is seen even in the atmosphere only model where SST is fixed, right? So how do you justify that?
So the first is so first work is done there, but suppose the Krishnamurti's work is there on this dry intrusion, they mostly did in that work they did a back trajectory analysis. They said that during over the like west from the West Asia that dry intrusion come, but in that work they said that the presence of the moisture deficit over the Arabian Sea, west of Arabian Sea, and I mean, this the presence of that moisture in the West Arabian Sea, this comes from the this advection is done by the low level jet of monsoon, not just coming from that region. So they identified that the variability in the monsoon low level jet could also create that intrusion in that region.
I mean, nothing looks okay. I mean, you are not the author, so I'm not blaming you, but most of this is already known. I mean, somebody should ask Sandeep Sukumar what is new in this. Because, I mean, we know that jet vehicles, when there is a break spell. Okay, and it's a kind of related to the Indian, the Indian region and the European one. So they're all related to each other. So I don't see anything new coming in this. I mean, you don't have to go, I'm not blaming you, I'm saying, I don't see anything new if you go back to any of the classical papers. Maybe you should read them from Sikras and to Slochna's paper on review. You'll see that there is a lot of all this done, and even Venu's work, which they test on. They're all talking about the same things. So I don't see anything new, but that's okay.
They just like said that.
Repackaging the whole thing. That's all.
Okay, any other question? Okay, thank you. Yeah. Thank you. So we almost completed 3 months of the monsoon, okay? And things are going rather smoothly. And we have only a deficit of 11% in June. July was +9, August is +15%. Okay. There are only 3 more days to go. So I think it will remain around 15% in my opinion. And that I don't think anyone predicted that. This is a surprising part. And of course, all India is at about 7%. So if September is normal, then the prediction by IMD will be exactly right. IMD said 6%. Okay. So IMD is on track to become a good forecaster of this. Now, but you see a lot of variation within the country. Okay, I just wanted to see a very interesting thing from South, where it's in India. Look at the Tamil Nadu. I never seen this. I never saw Tamil Nadu getting 68% above normal rainfall in June, July, August. Never seen it. Okay, maybe I have to check the data. And I remember only 2 weeks back it was 100% above normal. Now it has weakened a little bit and gone. So it's very remarkable. I would like to know how, in Kerala there, how does the rainfall get into Tamil Nadu? What is the system? I don't think people, because normally due to August, rainfall is pretty low in Tamil Nadu and people don't probably study it. So it's very interesting results this year. And of course, we also have pretty good rainfall in South India, Karnataka, but nothing like Tamil Nadu. Okay? And you see Kerala, in spite of Wayanad, is 14% below normal. Okay? And so both other places are okay. Of course, these are very far, Lakshadweep and Andaman are far away from us. Then let's look at North India. Again, within this broad subdivision, there's high variability. Look at here, Rajasthan got 70% above, and all these states which usually have drought conditions in the last few years, all of them are there except for Uttarakhand, which is of course partly Oregon or Western Desert. That I would exclude, but all these are below normal except Rajasthan. Okay, and even Uttar Pradesh continues to be below normal. Then come to central India, only Orissa is 10% below normal. Okay, now that surprises me because look at the traditional climatology of Indian monsoon rainfall. The highest value is in Orissa, and it goes down to Rajasthan, right? That's where the depressions and lows go up. Maybe it didn't happen this year. We'll see that. So that issue should be looked at. how come Orissa is the only area in southern India that is below normal? Okay, now this is data given by IMD. I was surprised, I didn't look at it earlier. They provide a real-time discussion on what's going on. Okay, it's not easy to find out, but you can figure it out. I find the best way, if a website is very poor, you do a Google search, it'll get you the correct thing, right? I got to Google search and look at this. June, July combined. August, they have not completed that part. So the number of low pressure system days, okay, was 24. Okay, sorry, was 7, half of climatology. Okay. So those people who swear by LPS and depression wave should know that it has no correction to rainfall. The rainfall above normal, but the number of low pressure days is half of climatology. And number of days, they may say, okay, the number may be small, maybe it was there for longer. No, even this. So I don't understand the role played by these systems in actually getting the rainfall, because that part is not clear from this data. Yeah, I'm sorry. This includes. They said June, they include August, so August include, I'm sorry. But September exclude. This is a wrong title. So they include till I think last week. Okay, now let's see what are the forecasts so far. So the only people who are willing to forecast monthly mean is SkyMet. Okay, they don't mind getting it wrong. They make bigger prediction all the time. Okay, so they said June was 95, was 89. I would say outside the error bar. 105, 109 pretty close. The error bar is 5% pretty close. This is way off. Okay? This is my estimate because I added 4 more days of normal rainfall and I got 115%. So, of course, ultimately, when you add, they may get it right. Okay, so what is remarkable about the core monsoon zone in the last week is this. Okay, remember last few weeks we were saying how core monsoon was looking like a break, but really it was not that. It revived and hit numbers like 20 millimeters per day. Okay, that is not common. So I still don't understand with less number of low pressure system, less number of LPS days, how is the monsoon working? So I don't know. This is one thing which really, on a synoptic scale, surprised me. For 5 days, the monsoon was very vigorous over the core monsoon zone, and it will continue to be so in the next few days. Okay, this is the, we like to do standardized anomalies that clearly, again showing compared to the long period of not break, but weaker monsoon, suddenly it revived just in the last 5 days. And that has resulted, that's what surprised me. You start from about 1st August, it was mostly below normal. And then the last 3-4 days, you're getting plus 15%, which is bit surprising. Okay. Now let's look at the state of Nino 3.4. It refuses to go to negative values. Okay, this is most puzzling and showing that almost all the forecasts are wrong. All of them are saying it will be negative or La Nina by now, all of them. Okay, so this is the point which interested me when I was not here, but something problem with the coupled model forecast. Okay, so what really happened was they got this right. Okay, then it just stalled. Okay. Last 3 months it was hanging around zero, refusing to go down. Okay. Only 2 of the models got it right. I don't know what these models are, APCC and MT, I don't know what the friends are. These 2 guys, but all the others were talking about La Nina. This is issued in May. Okay, now the reason is nice in this NOAA climate website. They are looking at various models, not named it. They are showing that the answer amplitude that we are interested in depends on a very fine balance between positive and negative factors. Okay. This is a typical problem when you deal with atmospheric motion. Lots of things are happening, the negative, and the final answer is a small difference in large groups. So in spite of that is a very good piece of work on coupled with atmospheric model, we are not able to get this right because there's so many of these processes working against each other, and the net difference in this. So that's, I think, a nice way to understand why predicting Nino 3.2 is not so easy. Okay, now go back to Arithnam's paper on the transition from El Nino to La Nina. Okay, so there are three ways that can happen. The best way would have been El Nino to go directly to La Nina by September. That didn't happen. It's gone. Okay, or it could have. We are actually on green line right now. We are hovering around zero. That's what we are. Okay, or it could have remained, and then that didn't happen, unfortunately. Okay, so we are on this thing which is quite rare. We'll see what the prospects are. And this is what I showed earlier. I can remind you, all the previous episodes of El Nino to La Nina transition, the trans occurred by August, when negative August. Only one guy was close to zero, that is 1983. Okay? That's the only thing which in September, but 83 was a plug year, so I don't really understand what 83 had, something else it had. Okay, now we go back to Arithnam's paper, and it highlights the challenge here. The challenge is that although this circuit is very difficult to understand, it takes time to figure out. You have to think about what happened in winter. In winter, we had a La Nina, El Nino, okay? That is this line. And if it had gone to La Nina in summer, then there is 99.8% chance that we'll get plus 9%. Okay? That is the statistical analysis. And so that was the basis of IMD's forecast, I think. That La Nina is going to come, and if it comes, this is the probability of that much. And interestingly, there's not too much variation between them, right? They're almost same. So once you get into La Nina, it doesn't matter what were the earlier winter conditions. Okay? But unfortunately, we are here in this today. Okay? We're going from El Nino to neutral. As of today, maybe 1 month later, I'll tell you something else. As of today, it looks like La Nina is not going to be dramatically coming in. So if that is the case, according to Aringham, there is a very high chance of it being below normal. Okay, that's not happening. I don't think. So that is what people ask me about. Looking at this data more closely to see whether September can. I still think that will trend down. Okay, if you look at the last 4 years, crazy things are happening in September. You know that 2019 was happening. So if that happens, then it's a good story. And who knows, I only made the rule. That possibility is always there. Okay, now I'd like to also call attention to a very nice statistic published by the Hyderabad group in IMD. They continuously monitor week after week how is the monsoons progressing this year compared to 5 previous years. Unfortunately, dates are not same. I wish they're the same dates, but they go by their weekly business. So each year really is different. Okay, that's only important part, but they have their own logic. So what it shows is this year, 71% of the districts, okay, we are talking about districts which is relevant for farming, not state or something. Those are all too big. District is a high parameter. So 71% of districts were normal and above normal. Okay. So that's very good news. In addition to the fact that we are 7% above normal. Then we have these 30 deficit, large deficit. So these two are very low. That means, sorry, these two are very low. So this year is better than last year. Last year at this point, it was 61 and so 71 and 39 and 29. Then let's go to 2022, similar to this year. You go back to 2021, it was pretty bad, 64 and 6. You go back to 2020, it was better than this year. And finally, 2019 was bad, but 2019, you know what happened in September. So let's keep that in mind when we go ahead in the next 4 weeks. Who knows, September might turn around here like it did in 2019. Okay. Now, these are the predictions made for all India rainfall. They are predicted plus 42%. I don't think it came out right. This is last week. Okay? And this week is plus 28, that may come out right. Now, here is the spatial pattern forecast for last week, slightly different dates, but the findings are not so good. Because plus 40%, minus 1%, totally wrong. Completely wrong in the where the rain occurred. Okay? So, a lot of things went wrong here. And maybe Gujarat is not bad, although the color is not same. Northeast is not big. Now, this is from the IMD website. They claim that the July monthly mean forecast was quite good. I disagree. I mean, to me, they couldn't get the huge negative here. They got a part of the negative here. They didn't get the negative here. Now, of course, Kashmir got it totally wrong. So, but they are quite certain. See, here they have done a good job. I'm happy for a long time using the almost same colors for both, so that we can make comparison. But I would say from this, looking at it, I would say it is somewhat of a failure because this large Indo-Gangetic plain got the wrong sun. Now let's see what's going to happen tomorrow, today to tomorrow. This is the forecast for, I'm sorry, this is forecast for today. So yeah. So both, I just want to look at short-term forecast. Yeah, of course, very close to each other. ECMW and GFS, that's not surprising. Short-term forecasts are getting extremely good. Now we come to what was the forecast for the next 2 weeks. Okay, not the 2 weeks, not 2 weeks, only 1 week. I'm sorry. Only 1 week of ECMW showed it has a different way, and it's showing this huge way that's going to happen in Gujarat and Pakistan, and a lot of rain over Bay of Bengal, which we will not care about. And this is the 2-week forecast from GFS. It's going to be very similar pattern, except for this portion of the slight deviation there. But otherwise, I would say they all have a high rainfall in Pakistan and low rainfall here. Now let's go to the ECMW forecast made on 1st June, okay, which I showed earlier. I'm just reminding you. I think they were very good. They said June is below normal, it was below normal. And if you got the number, it is 1 millimeter per day over 30 millimeters below normal. It was little less, maybe 20 to 23%. July, above normal, they were right, approximately right. August, they are right. September, they are above normal. So I would think seasonal forecast looks month-wise quite good compared to sky movement. Now I saw another interesting thing in the IMD website, and the website is so complicated, I cannot find it now. I don't know where it is. Some of you can search and find out. So what we're showing is in color schemes, not numerically, what we observe and what day 1, day 2, day 3, day 4, day 5. Okay? I'm showing it because I'm really surprised that you know what is surprising. There is hardly, you normally expect that day 1 forecast should be far better than day 5 forecast, right? Not there. 100% by this, maybe the color scheme, I don't know. To me, there's hardly any difference as the forecast gets longer and longer. So that is a bit of a problem. And as a day of 1 forecast, 25 compared to the Gujarat program.
This is an E or actual forecast. E or this is the actual rainfall, right? Not an E.
Yeah, the rainfall anomaly is shown in various ways. Yeah, actual rainfall, yeah. Anomalies here. The left top, supposedly they observe. The same thing shown for all the forecasts. Hardly any different. That's what's supposed to be. I expect big differences between 5 and 1, not them. I want to go to other this is in July, not August. But I could look at that. If somebody finds out, send me the website location. Okay. Now I come to what you discussed about why not. A lot of coverage in press about climate change, extreme events, all this tamasha which goes on whenever there is extreme event. Because now there is a villain to blame for everything. The villain is not here, there is somewhere else. Okay. So this is where it happened. And this is supposed to be one of the most wonderful sites for tourism. A lot of tourists died who had gone there. Now, if you look at the Hindu publication, they show a nice picture of what happened. So this is the place which was bad because this soil and then came running down this hill and covered the whole village. There's a different problem both in Uttarakhand and Himachal and Sikkim as well as Wayanad, that we have got heavy rain and there's not enough green cover on the slopes. It will come down. Okay. The question I have is, why does it happen every year? Because places like Wayanad get high rainfall almost year after year. Okay. There's nothing, we had a talk last week by a geologist. He didn't explain. He gave a very interesting talk about the state of the soil, the geology, and so on. But he couldn't explain why they got this year, not last year before. That issue is understood. Okay. Now, so I got this. I mentioned this. This is iron merge. So Kavita Ramkon managed to get this data, and it gives some hint. It shows that in the month of June, not when even the month of June is rained like crazy. Okay? 35 millimeters in a half an hour period. Okay? That's a very heavy rainfall compared to what we had last week here. Okay? So, and after that, there was a lull, again picked up, and after the soil was sufficiently saturated, I think, this last thing brought the condensate down, the last 30th July. Okay? So you do the cumulative, it's very large. I don't know what. So in the next few weeks, we get some more data and see whether this is a record for June, July or not. Okay? Because this kind of rainfall is quite common in Western Ghats, at least I know. I'll show some results. Okay, let's come back to Bangalore. Bangalore rainfall has been above normal, as all of you know. But what's interesting is look at these. We have now 4 stations, better than 1 and 2. So we see, as usual, that the highest rainfall used to occur in the heart of the city, lower in HL Airport, and lower in KL. But this is the surprise. I don't know what this is. This is just a few kilometers from here. And remember, last week we saw it rained, it didn't rain there. But now this rain is almost 200 millimeters above. Of course, this is not airport. The new airport is very far away. That's not. But I'm surprised this gradient is quite large for a seasonal mean. I mean, on a daily basis, season thing should average out. You should get a more uniform gradient. But this is surprising. I'll keep watching whether there's any problem there. But this is not an IMD station. This is a university maintained station. I will check with them about this. Okay. Now I mentioned this interesting phenomenon in Western Ghats. Okay. That 1 hour at 1,300 millimeters above normal, which really surprised me. Okay. Pretty large rainfall. Okay. And it had 4,000 millimeters. But at the same time, Agumbe, which is my favorite spot in Karnataka, was 5,600. It was below normal. Okay. So see that effect of orography. 1 hour has no orography. 1 hour is right on the coast. Okay. There are no mountain nearby. Agumbe is right at the heart where the Western Ghats starts. Okay. A lot of people who have not seen the map don't realize that in Karnataka, Western Ghats doesn't start at the coast. Well inside. Okay. So this is interesting. Because Agumbe for a long time was the highest rainfall station in Karnataka, but now there are a few more stations and people are competing as to who has got the highest.
They are not.
Okay.
They are not. Rainbow data is not there.
Huh?
So rainbow is usually higher than Agumbe.
Yeah, the problem is that's the problem. The Agumbe, I swear by, data goes back to 19th century. But others are new stations until you, it's like comparing The new airport data with Bangalore lines. It's hard to do. That's why they are smart. In Bangalore, they don't put climatology for chemical data. It is correct. We need 30 years data. Okay, here is the orography of the Western Ghats from one of the. I wish somebody would do a better job because I think there's a lot to be learned from the data of Western Ghats rainfall because orography is very complicated. And we need a high orography. I think the best is the radar data. This I don't know. I just saw an hour back at or something, and it's good or not. So somebody can try getting the better data. Now, what is about the data is from Cordoba to 1 hour. The mountains are quite far away. Nowhere near. And I don't know why people think so much only these 2 points. That's the surprising part. But now I'll come to what I like to see is Agumbe. Agumbe is right here. Okay. Very far away from both. But the key point, I think, in my opinion, I've not checked it yet, is the orientation. It is not south, just perpendicular to the Somali jet. Okay. That's a requirement to me. One of the summer students talked with me, but so I didn't get good enough answers yet. I believe a small change in the angle of the Somali jet has a huge impact on orographic rainfall. That's my hypothesis. But to prove that, I need very good orographic data because slight change in orientation of the mountain. For example, I remember when the student worked on it, he got some data, he couldn't get oriented because he got changed so rapidly. Okay. So to me, this will not get as great as this if the wind was truly from the west. Okay, so I just wanted to end by dot Wikipedia in Hulikal and Agumbe. So in Hulikal, 1 year got 9,383. They declared that Agumbe is gone, and everybody blaming on deforestation, climate change, any effects, is often. But next year, we see here, there's huge variation. I can't believe it, between 9,000 and 5,700 for orographic rain really surprises me. So I think there's a lot of scope. If you believe in IML data, that's the only data we have. Remember, we don't have stations to cover all these interesting areas. So we have to go by IML, which has its own problems. But still, I would like to explore that. So, what would like to know, because I'm scared of algorithm. So, I would like to know what will IML say about this location. Whether it will produce this variability that you see in rainfall in 9,000 and 5,000. I'm sure variability of this is much larger than ISO any. Here we have it. Okay, this is the last thing from IMD website. They do a verification in real time, comparing their heavy rainfall warning skill compared to other things, and they claim they are the best. Okay, I will not comment on it if you think about it, because I don't know what is the operational prediction, right? OP means that's I don't know what it is. So we are comparing with all models. Oh. And normally all we find very poor values. And GFS being so much better than ANSWER, I don't quite see how. The same model, right? Unless our resolution is much higher.
Yes, we will go over it with GFS.
Huh?
That's an ensemble forecast.
Oh.
And it is even worse. When
Yeah.
you take it 21
So anyway, I'm sure you know those people can find out what is their. Looks interesting, but somebody else to explain how come these guys are the best. Yeah, they don't. That means they use this for something else, right?
Yeah.
Some experience or I don't know what it is. Because I find the agriculture website, they have one. They have the model forecast and they call the modified forecast. I would like to know how they do it. It's interesting.
Maybe it's a
But every station they make one forecast for the next 1 week, and they say modulate on some word.
in
They
bias,
take the forecast and adjust it.
a bias correction.
Huh?
Bias correction process.
No.
Bias correction.
No, what can be bias correction? It's beyond that. I'm sure one of the bias correction. The whole model ended up to crime. You can't do that. So they do, I'm sure they do bias correction. Everyone does that.
Yeah.
I think doctor mathematician, you won't like it, but everyone does it. But this is something, boy, I want to ask somebody, what is that? What are the two forecasts they give? And somebody can compare the model forecast and the modified forecast with actual data to see how many days. But I think all this cannot be done because as you saw, there's so much spatial variation in rainfall over Bangalore. If you take a model forecast, model output now 30 to 38 kilometers, right? Typically, take you.
No, this would be short range forecast. It would be around 12 kilometers.
Yeah. So if you do that, like when you forecast for central college forecast for maybe not IISc, maybe and see the difference. Yeah, maybe, yeah. Okay, so that comes to the presentation. Any questions?
Forecast increases much after compared to EMW or GFL. The EMW could be 0.6 at the beginning, but the decrease is not much in day 5 or after day 5. Okay. But yeah, IMD slowed down drastically operating forecast.
Oh,
So I mean even income basically.
Yeah.
That income that's
Right.
0.77 to 0.7. So basically, by day 5, income models are overtaking the operating forecast.
yeah.
4, 5, basically.
I think that's what you said.
What I'm trying to say is that this the operating forecast possibly some little bit human, subjective little bit.
Yeah.
So that, yeah.
Opinion or something else.
Yeah, so my point is that if you have to do a long range forecast with more accuracy, still the models are better than that those kind of a subjective forecast.
But I can tell you, the day of climate change, subject judgment is very tough. I did a story from long time back. When a student in Stanford, find one day, snow, which is very rare. Coastline. I was told that the model forecast snowfall, the forecaster thought they cannot be right. So this can happen. Because we've experienced when things are changing rapidly, your experience may not be valid, right? So that's the point. I'm just curious, so if they're doing better, I would like to know what insight, experience, what input they should be not have in the model.
No, but they are, when we forecast, it's not that they don't do, they do not look at the model forecast, they look at the model forecast also.
Okay.
So on top of that, they have to.
What is it? So Ravi can find out what is it so that we can learn something. Because none of this public domain information. Okay, next week is.
What qualifies as LPS event?
Huh?
What qualifies as LPS event?
What do you mean?
Information system.
Huh?
You mentioned about LPS events a number of days.
Yeah.
What qualifies as an LPS event?
In terms of how to the pressure, they are defined. And every month is a separate question.
It's I know you define discretely, but it's a very subjective.
Very subjective.
For example, you can have, let's say, very elongated.
And then there are a number of contour lines.
Yeah.
I'm with the old fashioned thing before computers came. I'm not, I want quantitative thing and it's still not come. I would prefer a very strict criteria. I would be, but we've got enough data. The problem is number. Don't classify things because enough data, right? So I don't know how many surface pressure data we have to exact locations.
But yes, you can balance that very quite a bit. You can get some satellite derived range.
Surface pressure?
Surface pressure, no. But this surface pressure is fairly good in models. It's not very bad.
Okay.
And they use the criteria of both winds and the lowest surface pressure. And so many close quantities of 1 megapascal radius. I mean, you can have, for example, they elongate, let's say, trough.
Yeah.
It will rain, but there is really no close contours. Then I don't think IMD would classify that as LPS. But still, it would be raining. You know, I think that what was happening during that break we had maybe 2 weeks back or something. When the trough was persisting for ever, right?
Yeah.
And it was, I mean, otherwise, why would you have with a break have that, it gets rainfall? So I don't think that, I mean, there is, it's continuous. So I think they define that as, yeah, I'm not even clear about
Yeah.
it because I'm really defining a discrete thing, but it's a.
Yeah. I would like to put on website, whatever they do, because the website must have a clear, like the AML, the glossary, can go looking up what is CSI, everything like that. Whatever they are defining, they should have a place to.
In fact, this PhD, if you look at it, we had yesterday or something in Gujarat area, right? There was a delay because of the cyclonic circulation or whatever. But many times in the monsoon season, you see, I mean, you don't really have well-defined cyclone, but have diffuse trough would be there. So rainy can be there, but I don't think they would classify that diffuse trough as a PS. So yeah, it would be confusing because of that. If you count the PS and rainfall.
Yeah. Any other questions? No. Okay. So that's why Shankarta is in the town, right? Okay. The next note for you.
And